Hello, good morning. And today's topic is common potential of the two capacitors charged to different potential when they are connected by any metallic wire. Okay, so we will have two capacitors of different capacity. They are charged to different potentials when they are connected together. So they come to a common potential, and we have to find that common potential of the two capacitors. So say this is one capacitor, its capacity is C1 and it is charged to voltage V1. It is connected to another capacitor of capacity C2 and its voltage is V2. So when we connect them by any metallic wire, so what happens, some charge flows from high potential to a low potential, and for the sake of now consider that the V2 is less than V1. C1 is greater, we are letting right now, or it may or not be, it doesn't matter, but it is very important that that charge will flow from the high potential to the low potential and finally stops at a common potential when both the capacitors are coming to a common potential. Okay, so what will be the charge on this capacitor? Say it is Q1, so Q1 will be equal to C1 V1, that is charge on this capacitor, because we have already charged this capacitor to potential V1. Okay, so what will be the potential or charge on the second capacitor? That is Q2 is equal to C2 and V2, and in this process there may be production of some flashes or sparks, but remember this is an isolated system, and for any isolated system the total charge contained by the system will be 0 or constant. That is, if nothing comes out from the outside, then the total charge, that is Q1 plus Q2, will be constant for this particular isolated system. That is the principle of conservation of charge. Okay, now I am saying that when they are connected via this metallic wire, okay, this is a wire or metallic wire, so charge will flow from this to that particular capacitor and their potential finally becomes common, and that common potential is say V. That is, after some time this capacitor will be charged to potential V and this one as well at potential V. So this is the common potential, and we have to find that common potential's value. So if V is the now final potential, so after connecting, what happens? Charge flows from high potential to low potential. Okay, and now let V is the common potential. So now the new charge on the first capacitor, that is new charge on capacitor C1, that is Q1 and prime. Q1 prime is the new charge on the first body, is equal to its capacitance and its potential V. Now remember, this is not, and it will not be V1, because we have now come out of V1, it got to be V, and but capacitance does not change. It is decided by the manufacturer, right? Similarly, new charge on capacitor number 2, that is Q2 prime, is equal to C2V. Now by conservation of charge, no charge will be lost, or we are letting if no charge is lost during the connection or while making the connection, because most of the time you might have seen that when you connect two wires, there is plus or minus of a battery, there produces a spark, and that spark is simply what? A kind of electrical energy in terms of electromagnetic waves. So in that process there is no loss of charge, we are supposing, because the system has got to be isolated. It will lose some energy. Okay. Now by conservation of charge, it means we must have this final charge on C1 plus C2 is equal to what? Initial charge. What is the final charge? That is Q1 dash plus Q1 Q2 dash, and this is the final charge, and it will be equal to the sum of initial charge, that is Q1 plus Q2. Okay, now put the value of, that is C1V plus C2V is equal to C1V1 plus C2V2. Okay, this is the condition for the no loss of charges. This is so far quite easy. Now V is common, so V is equal to this whole, and okay, let's solve. C1 plus C2 is equal to C1V1 plus C2V2, so that V is equal to C1V1 plus C2V2 over C1 plus C2. This is the value of the common potential of the two capacitors. Now it means the system has now arrived at this common potential. Now what is the philosophy behind this? You can simply understand it by a common example. This is the physics tells about, this is the mathematics what we have done. Now we can understand in simple manner. Consider we have two containers. One is bigger and one is smaller, maybe of different heights and different volume, and this capacitor or this container is having liquid up to this level, and this is having liquid up to this level. Okay, say their heights are equal. So this is containing more amount of water and having its height even more, and its height is less and containing less amount of quantity. Obviously its capacity is high and that of this is low. But what happens if they are connected by any pipe? Obviously the liquid goes from this to that container, agree, and it continues to flow from this to that container unless until the level of the two liquids become equal in the two containers. And a time arrives when the height of this liquid decreases and its value increases. So suppose this height goes to this level. Now what happened? Now they are at the common height. The liquid level is at common height. So what happened in this process? That is, the liquid has flown from this to that particular container, but the flow of liquid continued till the height of the liquid in both the container became equal. So height can be compared with the potential. Height, in previous lecture we discussed about the height can be compared with potential, and the quantity, that is liquid, can be compared with charge. So if two containers having capacity of different values and containing different amount of quantities are connected through any pipe, then liquid flows from the container having liquid at the higher level, and finally it becomes to a equal level. That is, when the height of the liquid becomes equal in both the container, the flow of the liquid becomes constant, or it does not flow. Simply, the liquid will not flow. So we are comparing what? Height with voltage and liquid with capacity, charge, that is liquid. So we are comparing what? So height becomes equal, that is charge flow will continue until unless the height becomes equal in both the liquid, and height is compared with potential. So when they are at the common potential, their potential becomes equal, the flow of liquid simply stops. Okay, that is the concept of common potential. So we have the common potential is equal to C1 V1 plus C2 V2 over C1 plus C2. That's it. Okay, nothing else, very simple.